Hi, this is Jeff Heaton. Welcome to Applications of Deep Neural Networks with Washington University. There's a whole series of Atari-style video games on the OpenAI Gym. In this video, I'm going to show you how to use reinforcement learning to compete against those. For the latest on my AI course and projects, click subscribe and the bell next to it to be notified of every new video. Alright, now the fun part. We're going to see how to train this thing to play Atari video games. So the Atari 2600, if you're not familiar with it, there was really only one primary Atari game system at this point. Later they came up with a computer, the Atari ST, and there were other computers. But the Atari 2600 is the game system that we're dealing with here. And it has popular games. Combat and Pac Man were the games that typically came with it. There are virtual Ataris, so you can actually run this in JavaScript. Pretty much everything that can be written tends to be written in JavaScript. So we naturally have Atari emulators in JavaScript. So if we click on this, we can see that we can play Pac Man. And Pac Man, that was a huge game in the 1980s. If I get it going, I can basically play with my cursor keys, and my goal is to avoid the ghosts and try to eat these energy pellets that then let me eat the ghost. Now this is really primitive technology because you can see how the ghosts are flickering. That is because this game literally had more sprites than the hardware could handle. So it's essentially using two, I believe, of the hardware sprites and very rapidly flashing between them. It's pretty innovative actually, using the primitive hardware as it can. But that's why the ghosts are so flashy, because they're literally reusing some of the same sprites just over and over again. So this is virtual Atari. This is using JavaScript. There's also more efficient emulators like the Stella Atari emulator, and this is what the OpenAI Gym actually uses. Now the Stella Atari emulator does not work on Windows. A lot of these emulators can't really be ran on Windows, so you'll run into that issue if you try to run this on Windows. I'm actually running this on a Mac currently, so I'll be able to run that just fine. And by the way, this is what the real Atari 2600 video game system actually looks like from back in the day. Now, to be able to run this game, you're going to need to basically install the Atari emulator. And I did not put this as part of the class notes back when I told you how to install your environments, and you also can't do this in Google Colab, so you would need to install this. If you're running on Windows, or if you're running on Mac or Linux, this will be an easy install. I have instructions in the first part of this module on how you could try to do this on Windows. By the way, here are some of the specifications on the Atari. You can see that the playfield resolution is really pretty low resolution. That's why in some of these games, you can actually feed in the entire screen as input to the convolution neural network so that it learns what it can do. It also has only about 128 bytes of memory, so that means you can literally use the memory too as inputs. We're going to use the OpenAI Lab Atari Breakout. So it's this game that you see here on the screen. Essentially, you're playing ping pong with this little ball that is bouncing up here, and every time you hit this wall up here, you break out another piece. The goal is to eventually get the ball up here so that you've kind of broken out, so to speak. Now, just to run this, and I give you the full rules of the game up here, you have 4 discrete actions to move this little platform. You can move it up, down, left, and right. And this is the size of the playing screen. It's a 210 across, 160 down, and 3 pixels deep, 3 RGB deep, so it's red, green, and blue. And this comes entirely from the example code here on the Keras site. So I didn't reproduce their example code here because it's literally exactly the same. You would need to grab this as a PY file and download it and run it. I'm going to run it in a moment so you can see what it does. But essentially how this works, and by the way, this trains a long time. I had to leave this running overnight. I was running on a CPU machine. You could probably get this to run on Google Colab. You just couldn't see... Nah, I take that back. You would have to run the Atari emulator. You probably could. I have not tried it. But this will work best on your local environment. So what goes on here is they create a class that abstracts the Atari processor. So the idea is you could run this almost on any of the Atari games that you could. Processing the batch, processing the observation. So they try to really abstract this so that you can use this on multiple games. They do give you the chance that you can run it in train mode or test mode, because train runs all night. So I'm not going to retrain it literally while the video is rolling. Rather, we're going to run it in test mode just so that you can see it actually play. Plays quite well, actually. This is all similar to the cart pull. We're creating a random environment. We're passing in the environment name, which is Breakout. Oh, right. Breakout deterministic. So this is a variant of Breakout that has no randomness in it, which makes it a little bit easier to learn. We then create the actual neural network that is here. You'll notice that we are definitely using convolution neural networks, so 3 convolution layers, because this is very much an image processing problem, because we are getting the screen actually passed to us, and we have to decide if we want to go up, down, left, or right, just based on the screen. So it needs to learn to see that little ball. It needs to learn to see the bars up at the top. I find it fascinating that the convolution neural network is truly learning to have that little paddle chase the ball as it moves around. That's very cool. And then we set it all up. We use the same DQN agent that we had for the cart pull in the previous video, and we set it up. If we're training, we save these weights as we go, because this can take a long time. You may want to take the weights for one individual process and try them out on another computer and see if you're really getting good results. And you might be done. You could stop it at any point. And then if you do want to test it, it's going to actually load it and run it. It's going to run it for 10 episodes, so you'll see 10 games played. Let's go ahead and run it. So I'm going to open up a terminal window. You just run it Python Atari PY. So we need to specify mode as test. Otherwise, it's going to try to retrain the whole thing, which we don't want to do. I spent last night doing that. Or my computer did. I didn't do any work. And here you can see it's basically running through. It's chasing the ball. It is doing really quite well. It is knocking out quite a few of those squares up there. And we'll let it just go ahead and run through its 10 iterations, and you can see how well deep reinforcement learning can actually learn to play this Atari game. Thank you for watching this video. In the next video, we're going to have a look at AlphaZero and see how it used some of the technologies that we've looked at in this course to achieve chess superiority against human and computer opponents alike. This content changes often, so subscribe to the channel to stay up to date on this course and other topics in artificial intelligence.